Hello everyone! Welcome to Teacher Hanji's channel. For today's tutorial, we will prove theorems on the different kinds of parallelograms. So first, let us define what is theorem. Remember that a theorem is a statement that can be demonstrated to be true by accepted mathematical operations and arguments. And the process of showing a theorem to be correct is called proof. In other words, a proof is an explanation of why a statement is true or correct. In fact, there are many theorems behind parallelograms. But let us focus first in the first four theorems of parallelogram. First, the diagonals of rectangles are congruent. Second, the diagonals of a rhombus are perpendicular to each other. Third, each diagonals of rhombus bisect its opposite angles. And fourth, in a square, each diagonal forms two congruent isosceles right triangles. So let us start first with our first theorems that the diagonals of a rectangles are congruent. Let's say that this is our figure. Given that rectangle ABCD with diagonals AC and BB, let us prove that diagonal AC is congruent to diagonals DB as stated to our theorem. So to prove that diagonal AC is congruent to diagonal DB, we will use a two-column proof in which we have here the statements and the reasons. So for our statement, let us start first with the statement rectangle ABCD with diagonals AC and DB. So for our reason, of course, it came from our given. Next, since we know that this one is a rectangle, then we can say that side AB is congruent to side DC. This one, side AB, is congruent to side DC. For the opposite angles of rectangles are congruent. And as for the statement number 3, we can say that angle BAD and angle CDA are right angles. It is based on the definition of the rectangle in which it contains 4 right angles. Then since these two angles are right angles, then we can say that angle BAD is congruent to angle CDA since it both measures 90 degrees. For the reason, any two right angles are congruent. So if you notice, we have here two opposite sides which are congruent and two angles that are congruent to one another. So let's have another one. So let's say that AD is congruent to BA by reflexive properties. So if you notice, we have here now side angle side and side angle side. Therefore, we can say that triangle BAD is congruent to triangle CDA for the reason of SAS postulate. And since we know that triangle BAD is congruent to triangle CDA, then we can say that diagonal AC is congruent to diagonal BD for the reason of CPCTC or corresponding parts of congruent triangles are congruent. So therefore, the theorem the diagonals of a rectangle are congruent is true. Now we are done with our first theorems. Let us move on with our second theorem that the diagonals of a rhombus are perpendicular to each other. Remember that when we say perpendicular, it means that the lines or the diagonals here should form a right angle. So, from our given, the rhombus like with diagonals LK and IE. And let us prove that diagonal LK is perpendicular to diagonal IE. It means it should form a right angles. So let us now use our two-column proof with the statements and reasons. So again, like what we did in our first example, we will start with the given, the rhombus like with diagonals LK and IE, and that is the given. And since we know that this figure is a rhombus, then we can say that side LI is congruent to side IK and congruent to side KE, also congruent to side EN, for the reason of the definition of the rhombus in which all sides are congruent. For our third statement, we have diagonal LK and IE bisect each other at N. So as for our reason, we will use the properties of parallelograms in which the diagonals of parallelogram bisect each other. And since we use these properties, then we can say that LM is congruent to KM. This one, LM is congruent to KM for the definition of bisector. So we have here two pairs of congruent sides. Let's have another one to prove that the triangles are congruent. So we have IM is congruent to IN by reflexive properties. So if you notice, we have here side, 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 and side, side, side congruent. So it means that triangle LMI is congruent to triangle KMI for the reason of SSS postulate. Since we know that these two triangles are congruent, we can now say that angle 1 and angle 2 are congruent. As for the reason, the corresponding parts of congruent triangles are congruent. So from the position of our angle 1 and angle 2, we can say that angle 1 and angle 2 form a linear pair. It is from the definition of the linear pair. So it means that the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. So again, this is for the linear pair postulate. So for our statement number 10, we can say that angle 1 and angle 2 are right angles. So instead of using these markings, we will use the square marks to show that these two are right angles. So for the reason, if two angles are both congruent as measured in number 7 statement and supplementary as mentioned in number 9 statement, then they are right angles. Since we know that angle 1 and 2 are right angles, then we can prove that diagonal LK is perpendicular to diagonal IE as they form a right angles, and from the definition of perpendicular lines. So that's it. We can see that the theorem diagonals of a rhombus are perpendicular to each other. Let us now move on with our third theorems. Each diagonals of a rhombus bisect its opposite angle. So let's say that this is our figure, and from the given, the rhombus love with diagonal OE, and let us prove that angle 1 is congruent to angle 4, angle 3 is congruent to angle 2. Using the two-column proof, our statement and reason should be stated. So let's start first with the given that rhombus love with diagonal OE. So for the reason, of course, it came from our given. And since we know that this figure is a rhombus, then we can say that side LO is congruent to side OB and congruent to side VE and congruent to side EN. From the definition of the rhombus in which all sides should be congruent. And since we know that this is a parallelogram, then we can use the properties of parallelogram in which angle L is congruent to angle V by the opposite angles of parallelograms are congruent. So we have here now side, angle, side. Then we can now say that triangle OLE is congruent to triangle OVE by SAS postulate. So for our fifth statement, we have triangle OLE and triangle OVE are isosceles triangles by the definition of isosceles triangles in which the two sides should be equal. Since we know that these triangles are isosceles and congruent, then we can say that angle 1 and angle 2 are congruent angle 3 and angle 4 are congruent by CPCTC, or corresponding parts of congruent triangles are congruent. Let us have statement number 7. Angle 1 and angle 3 are congruent. Angle 2 and angle 4 are congruent for the reason of definition of isosceles triangles in which the angle opposite to the equal sides are congruent. So from statement number 6 and number 7, we can now prove that angle 1 is congruent to angle 4 and angle 3 is congruent to angle 2 by transitive property. So that is how we prove that the diagonals of a rhombus bisect its opposite angle. So let us have our fourth and last theorems in which in a square, each diagonal forms two congruent isosceles right triangles. So let us say that this is our figure, and as for our given, rose is a square. So let us prove the triangle RES is congruent to triangle SOR, and triangle RES and triangle SOR are isosceles right triangles. So we prove this theorem. So again, we will use our two-column proof with the statements and reasons. So let us start first with the given. Rose is a square. So it means that side RO is congruent to side OS, is congruent to side SE, is congruent to side ER. So by the definition of square, that all sides are congruent. So we have here two pairs of congruent sides. So let us have our third statement. So let's say that RS is congruent to SR by reflexive property. And since we have here three pairs of congruent sides, then we can say that triangle RES is congruent to triangle SOR by SSS postulate. So we have proved that triangle RES is congruent to triangle SOR. This time, let us prove the second statement. The triangle RES and triangle SOR are isosceles right triangles. So let us have our fifth statement. Triangle RES and triangle SOR are isosceles triangles. Why? Because of the definition of isosceles triangle, therefore angle E and angle O are right angles, in which angle E measures 90 degrees and angle O measures 90 degrees as well, by the definition of the square in which it has four right angles. Therefore, we can say now that triangle RES and triangle SOR are isosceles right triangles by the definition of isosceles right triangles. So that is how we prove theorems on the different kinds of parallelograms, the rectangle, the rhombus, and the square. So that's it for our video. Thank you for watching. See you again in my next video. Bye!